All right, you are about to dive deep into learning about Newton's 3 laws of motion. So I just want to take this time to quickly just give you an overview of how all these assignments are going to work together to teach you these concepts of the laws of motion. So I'm just going to cover in the slides. We'll talk about the first law, which is the law of inertia, the second law, the law of momentum, and the third law, the law of action and reaction. And then we'll just kind of look at some examples of how those are in daily life. So how you just see them in everything you're doing in a day, and how it's impacted by design, how design, I should say, is impacted by Newton's laws of motions. So we have 3 laws. Again, you're going to dive into these pretty deep. You've got the law of inertia. The law of inertia, Newton's first law. It's talking about how an object is at rest will stay at rest, but an object that's in motion will stay in motion. And in both those cases, they will continue in that state unless there's an external force that acts on it. The second law, the law of acceleration, is looking at force being equal to mass of an object times its acceleration. So how force, mass, can impact acceleration of an object. And then the third law is the law of action and reaction. So for every action, there's an equal and opposite reaction. So the first law, the law of inertia, again, that's just an object is going to stay at rest or in motion. It'll be at the same speed in motion unless there's an unbalanced force that acts upon it. And we'll give you some examples of this. So inertia would really be looking at a car, like if somebody hits the brakes, but the objects in the car continue to move forward, even though the vehicle was stopped. That's the law of inertia. So that object that was in motion wants to stay at motion, and applying the brakes is the unbalanced force to change that state. Motions in space would be astronauts just kind of floating in space due to the absence of gravity. They will stay just kind of going in that state of motion unless there's an unbalanced force that acts on it. And then the third example would be an object that's at rest. So a ball that's on the ground, such as this, would just stay there unless some unbalanced force comes and acts upon it. Okay, so Newton's second law, the law of momentum, again, is really looking at the relationship between force, mass, and acceleration. So the formula is going to be force equals mass times acceleration. F stands for force, M is mass, A is acceleration. You're going to be doing a lot of work with this in one of the lessons coming up. So I won't spend too much time here breaking down this formula for you, but just thinking about force relation to how much mass there is, and that will impact the acceleration. So we'll see that with cars, car acceleration. Kicking a ball, again, that ball is going to stay stationary. What force is needed to make it move? And then the same with swinging a bat to hit a baseball, and then observing the force to make that baseball accelerate. The third law, the law of action and reaction. So for every action, there's an equal and opposite reaction. So if one object is exerting a force on a second object, that object's going to exert a force back to that first object. Again, you're going to be learning, doing a lot with this and getting some good examples of this, but here's how we might see it in real life. So if you're trying to swim and you're pushing against the water, and the water pushes back, and that's what propels the swimmer forward. Rocket propulsion. Rockets propel forward. They go up by expelling that gas backwards, so the equal and opposite reaction. And then just even the simple everyday just walking around. So when you walk, you're going to push your foot down on the ground, and the ground's going to push back up on you, and that's going to allow you to move forward. So again, you'll be doing a lot with this coming up. All right, so I'll recap it quick. Here's some ways that this is, you might see this in real life. We talked about a seatbelt because of the first law. If you're in motion, you want to stay in motion. So it's important to have a seatbelt because if somebody hits on the brakes, the seatbelt helps your body stop moving forward. It's a safety feature, keeps you safe, and you'll learn about other safety features as well in a lab that you're going to do. Newton's second law helps us understand that the force that's required to push or pull an object to different masses. And then in the third one, you talk about action and reaction. So again, swimming, walking, that type of thing. How do Newton's laws of motion that we just kind of take for granted, I think, in our everyday life, how do these actually help with design and physics and engineering and that type of thing? All right, so there's your final recap. Law 1, Law 2, Law 3. Get busy, get to work, and I hope that you find this really enjoyable. I think you'll kind of start to see the world in a different perspective, knowing these 3 laws of motion.